So welcome to the next video. So in this video I'll be explaining shortest job first algorithm, shortest job first scheduling algorithm, and with that, along with that, I'll be taking multiple examples so that you can follow the complete algorithm in a much more better way. Alright. Okay, so this is non-preemptive schedule. So shortest job first says whatever ready processes you are having in the system, alright, your operating system will be scheduling only that process which is having the least amount of burst time. Okay. So after example it will be much more clear. Okay. Just as of now, hold on. So this is the non-preemptive schedule. Okay. So there is one another preemptive version of the shortest job first, and that is called shortest remaining time first. So we'll be seeing this in later videos. Okay. So let's take the example so that things become very much clear to you. Okay. This is the given question. I have just copied this part. Okay. Process IDs, arrival time, and burst times. Okay. I'll be finishing this table and I'll be making the Gantt chart as well, so that everything becomes very much easier for you to understand. Okay. At time t equal to 0, what will happen? Your CPU is starting. Okay, and by this time in your system only process 1 is available. Okay, so process 1 is scheduled. So as this is non-preemptive, this process P1 will keep on executing till its completion. All right. So when this P1 will be completed at time t equal to 4. All right. By the time you are at time t equal to 4, now in your system you have process 2, process 3 and process 4, because their arrival times are lesser than this time t equal to 4. So now by this time 4, as I have already said, P2, P3, P4, all of them are in system. So now given that P2, P3, P4, all of these three are in our system, we will be picking that process with the least burst time. Who is having the least burst time? That is process P4. If you see, that is 1 only. So up to t equal to 5, this P4 will keep on going. Alright. Then we have this, already we have executed this thing, and 1 and 4 both. Okay. 2 and 3, these two are pending. And which one is having the least amount of burst time? That is process 3. So process 3 will be scheduled and burst time is 2, that is P5 plus 2 is 7. Then process 2 and burst time is 3, that is 7 plus 3 is equal to 10. Alright, let me change the color. So what is the completion time of process P1? That is 4. Okay, this thing. What is the completion time of process P2? That is 10. What is the completion time of process P3? That is 7. What is the completion time of process P4? That is 5. So turnaround time will be completion time minus arrival time. And what is that? 4. 4 minus 0 is 4. 10 minus 1 is 9. Okay. 7 minus 2 is 5. 5 minus 3 is how much? 2. And what is the burst time? As I have already told you, that turnaround time equal to wait time plus burst time. So burst time equal to how much? Turnaround time minus wait time. So this is turnaround time. This is the how much? Sorry, once again. So this has to be wait time. Alright, this has to be wait time. So wait time will be, just let me clear it. So wait time will be turnaround time minus burst time. So if I told you that turnaround time minus burst time, okay, I will be getting this wait time. So 4 minus 4 is 0, 9 minus 3 is 6, 5 minus 2 is 3, 2 minus 1 is how much? 1. Now let me calculate the response time as well. What is the response time? So response time is the time duration between the arrival and the time in which the process is scheduled for the first time. When P1 has arrived at time t equal to 0, when it is scheduled at 0. So what is the difference? That is 0. When this time P2 has arrived at 1, t equal to 1, and when it is scheduled for the first time, that is 7. So 7 minus 1 is 6. When this process P3 has arrived at time t equal to 2, when it is scheduled at 5. So 5 minus 2 is 3. When this P4 has arrived, time equal to 3, and when it is scheduled at time t equal to 4. 4 minus 3 is 1. So now let's move to the next part of the video. So what is the schedule length? Schedule length I have already told you. I have already given you multiple times the example in the previous videos. So maximum of completion time across all the processes minus minimum of arrival time across all the processes. So what is the maximum of completion time across all the processes? That is 10. And what is the minimum arrival time? That is 0. That is 0. That is 10. Alright. So what is the throughput? Throughput will be what is the number of processes are there which is getting executed, I mean which are already executed, that is 4. And what is the length of the schedule? That is 10. So that is 2 by 5, that is 0.4. This is the throughput. Alright. So here in shortest job first there is a problem, and that problem is called starvation problem. Okay. So let me try to take an example. Let's say this is the CPU. Okay. By this dot I mean a process with low burst time, and by a big circle I mean this process is having much more higher burst time. Alright. Now let's assume at time t equal to 0 there is CPU, and you have these many small processes. Okay, let's say these all are 1 unit of time, and there is a big process with 100 unit of time burst time. Alright. So what your CPU will do? CPU will be executing all the small processes, then only your CPU can execute this big process. But let's say when your CPU is executing the small processes, let's say during that time another 100 small processes arrived. So what will happen? Now your CPU has to complete all these processes also. Then only your CPU can start with this big process. Let's say by the time these and this is done, let's say another batch of these small processes has arrived. Okay. Then again this big process is delayed. Even though this big process came at time t equal to 0, this is getting delayed and delayed and delayed because processes with comparatively smaller time have kept on coming. Alright, that is why your CPU kept on executing those small processes instead of that early arrived large process. So this is the starvation problem, and we call this big process is getting suffered from starvation. Alright, so smaller burst time processes keep on coming and high burst time process will keep on waiting. Something like this example. Alright, this is called starvation problem. So in SJF we can see this starvation problem. Now let's move to the next part of the video. So now in this part I have written how do you pick different processes. Okay, so pick process with least burst time. There is no confusion. You will have to always pick the process which is having least amount of burst time. Okay, let's say two processes are having the same burst time. Okay, so you will have to pick the process with lesser arrival time, so that why so? So that it reduces this wait time. Alright. So the process that has arrived early, I will be picking that process when there are conflict between two processes with the same burst time. Okay. So if there is same arrival time, so what we will be doing? We will be picking process with lesser process ID. Alright. This is the conflict resolution technique. So this is a general conflict resolution technique, but if the question expects you to follow some other conflict resolution technique, that will be mentioned. Don't worry. Okay, now let's take this example. So now let's take this example, and as always I have not filled this table and I have not made the Gantt chart so that I can make it in front of you and you can better understand it. Alright, your Gantt chart is starting at time t equal to 0. At time t equal to 0, which processes are you having in your system? So that is as of now process 1 only. Alright, and what is the burst time? That is 4. So process 1 is scheduled and it is executing till the time t equal to 4. So by the time you arrive at time t equal to 4 in the system, you have all the processes, because the arrival times of all these processes are lesser than equal to this time t equal to 4. Now what will happen? Your operating system will be choosing among this P2, P3, P4, P5 which process is having least amount of burst time. So what is the least amount of burst time? That is this one, that is 3. So P4 is scheduled here. Alright. So up to which point P4 will keep on executing? So the burst time of P4 is 3 unit. So 4 plus 3 is equal to 7. Alright. Now your operating system will be choosing the next least burst time. So which process is having now the least burst time? Among 6, 7, 9, that is this one, that is P3. Alright. Let's schedule P3 here. So what will happen? 7 plus 6 is 13. Alright. This is the 6 is the burst time, and from 7 it is getting scheduled. So 7 plus 6, 13, P3 will be finished. So now this P3 is also done, P1 is also done. Okay. Now is remaining is P2 and P5. So burst time of P2, how much? That is 7. So 13 plus 7 is 20. Alright. Then we come at P5. Okay. What is the burst time of P5? That is 9. So 20 plus 9 is 29. Alright. So what is the completion time of process P1? So that is 4. Okay, let me change the color. That is 4. What is the completion time of process P2? That is 20. Alright. What is the completion time of process P3? That is, let me check, 13. Completion time of process P4 is how much? 7. Completion time of process P5, how much is that? 29. Now, what is the turnaround time? As we all know, turnaround time is the completion time minus arrival time. If you don't know how it is, please go back to the older videos and follow the playlist. Alright. So turnaround time will be this completion time minus arrival time. What will happen? 4 minus 0 is 4. 20 minus 1 is 19. Okay. This 13 minus 2 is how much? 11. 17 minus 3 is how much? 4. 29 minus 4 is how much? 25. Wait time is the time between the arrival and the time in which the process is getting scheduled for the first time. What is this duration? So this duration is called response time. Alright. So okay, I will come to this response time later. Let me finish this wait time. So what is this wait time? We know turnaround time equal to wait time plus burst time. So this wait time will be turnaround time minus burst time. Alright. So if I calculate this turnaround time minus burst time, 4 minus 4 is how much? 0. 19 minus 7 is how much? 12. Alright. 11 minus 6 is 5. 4 minus 3 is how much? 1. 25 minus 9 is how much? 16. Now what is the response time? So I have already told you the time duration between the arrival and the time in which the process is scheduled for the first time. Now let me calculate the response time of process P1. When this process P1 has arrived at time t equal to 0, when it is scheduled for the first time, that is also 0. See, when this process P2 has arrived at time t equal to 1, and when it is scheduled for the first time, that is 13. So 13 minus 1 is 12. Alright. When this process P3 has arrived at time t equal to 2, and when it is scheduled, that is time t equal to 7. So 7 minus 2 is 5. So when this process P4 has arrived at time t equal to 3, when it is scheduled for the first time, that is time t equal to 4. So what is the response time? 4 minus 3 is 1. Okay. So when this process P5 has arrived, that time equal to 4. Alright. And when it is scheduled for the first time, that is time t equal to 20. So 20 minus 4 is 16. Alright. So now let's see the schedule length. What is schedule length? Maximum of across all the processes, what is the maximum completion time, minus across all the processes, what is the minimum arrival time. So if you see the Gantt chart, across all the possible processes, what is the maximum completion time? That is 29. Okay, that is 29. Minus across all the processes, which one is the minimum arrival time? That is 0. So schedule length is 29. Okay. So the schedule length is how much? 29. What is the throughput? Throughput is number of processes divided by schedule length. So 5 is the number of processes, and what is the schedule length? That is 29. Alright. So this is how much? 0.17. Alright. This is the throughput of the system.